Hello friends, up till now we have discussed the methods that we use to solve the quadratic equations, and we have discussed the factorization method, and we have also discussed the Shidracharya method. Well, now is the time for us to discuss solving the quadratic equation and finding out the nature of the roots. So what do we mean by nature of the roots, and what do we mean by roots? Roots means the two values of x, the two values that will satisfy the equation. And in quadratic equations, why two values? Because in quadratic equations there are two solutions. The degree or the highest power is 2 in these kind of equations, and there are two solutions to these kind of equations. So the two solutions that we have found out, they are basically called the roots of the equation, and we have to basically now determine what is the nature of roots. And what do we mean by nature of roots? Whether they are real or whether they are imaginary numbers. For example, -1, the square root of -1 is an imaginary number, so this is an imaginary number. On the other hand, square root of 3 is a real number. So the first thing that we determine is whether the roots are real or imaginary in nature, and second thing that we determine is whether the roots are equal or they are unequal, which means the two values that we have got as the solution of the quadratic equation, are they equal? Are these two values equal, or in other words, are these two values the same, or are these values different? So for any equation ax square plus bx plus c is equal to 0, you know already, we have discussed this in the earlier discussion that we had, in the earlier session that we had, that the roots of this particular equation, this is a quadratic equation, there is got to be two roots, and the roots of these equation will be x equal to minus b plus minus root b square minus 4ac by 2a. Now, what is the nature of roots? I have just now talked about the different types of roots that are possible, real and imaginary, and equal or unequal. So this is what we have to determine. And how do we determine it? See, you look at the b square minus 4ac. If you look here, you will find that we are basically talking about the square root. So if you look at this particular term, so we are basically using this particular term to find out the nature of the roots, and we are saying if b square minus 4ac is equal to 0, the roots would be real and equal. Now what do we mean by this, and why does this happen? See, basically you understood that basically this is how we have to find the roots. X is equal to minus b plus minus root b square minus 4ac by 2a. And why do we have two different values of the roots? Because in one case, what we do, we add up minus b to this particular value. Minus b is added to this particular value which we obtain, that is root b square minus 4ac, and then we divide it by 2a. In the other case, what we do is we subtract this particular value, that is root b square minus 4ac, from minus b, and then we divide the number with 2a. So that is why we basically get two different roots. Is this okay? Which means if somehow the value of this particular number, this particular expression root b square minus 4ac becomes 0, then there would be just one value which you will get, minus b plus minus 0. So minus b plus 0 will also be minus b, and minus b minus 0 would also be minus b, and in that case the value of the two roots, we would basically be getting just one value, because this whole term, if this becomes 0, then naturally the value of x will be equal to minus b divided by 2a. Is this making sense? So x will be equal to minus b divided by 2a, which means we would be getting just one value. But since it is a quadratic equation, there are got to be two different values of x, which satisfy this equation. And so rather than saying that we have got just one root or just one value for x, what we will say, we have basically got two values, but both of them are equal, and both of them are equal to minus b by 2a. So the two roots that we would be getting in such kind of a situation would be equal in value. Is that fine? And that is why we say that if b square minus 4 is equal to 0, we will get real and equal roots. Is this understood? And why is it real? Real is, I told you, imaginary is when you are getting a negative sign inside the square root. You cannot find out, let's say, this particular number. This is basically an imaginary number because you know that there is no number of which the square is negative. So you cannot have any number of which the square is negative. So naturally, if you are trying to find out the square root of a negative number, this is just not possible. So the square root would only be imaginary. However, this would not be the case here because the whole value root b square minus 4ac comes out to be 0, and I will be minus b, so that is why I will be having real roots. I will be having equal roots because this becomes 0, and the root that I will get would be minus b by 2a, and that is why I am having real and equal roots. On the other hand, if b square minus 4ac is greater than 0, this particular value is greater than 0, then naturally I will get two different roots, because two different values, I will be basically getting a particular number here, and I will be first adding it to minus b, and then I will be subtracting it from minus b. So naturally I will be getting two different numbers, and my roots would be distinct or unequal. They would be different. So I would basically be getting two roots of which the value is very different from each other, and they are real because b square minus 4ac is greater than 0. There is no negative value inside the square root. B square minus 4ac is greater than 0, it has to be positive, so I am going to get real roots. On the other hand, if b square minus 4ac is less than 0, the roots would be imaginary. Why would they be imaginary? The reason is very simple, that if this value, again this value, have a look at the top right corner of the slide, if this value is less than 0, it is just not possible for us to find out the, just like the example I mentioned here, it could be minus 1, it could be minus 2, or it could be minus 3 or minus 4, and it is just not possible for us to find out the square root of a negative value, and that is why we will be having imaginary roots here. Is this okay? Now let us talk about one more nature of the roots, and the nature is that the sum of these roots, which means the sum of the two roots you are going to get, is going to be minus b by a. Please keep this in mind, and please remember the minus sign always. You students tend to forget the minus sign and they make a mistake while doing the calculation. So the sum of roots has got to be minus b by a, while the product of these roots, which means the two values that will be there, the product is got to be c by a. So rather than finding out the roots of the equation, finding out the two values of the x that satisfy the equation, what we can do is, and if we want to find out the sum of the roots, we will have to first of all find out the two values of x, and then we'll have to add them up, or in case we are interested in finding the product, we'll have to multiply them. Rather than taking this long drawn process, what we can do rather is, we can simply use this particular formula, sum is equal to minus b by a. So when I am saying minus b by a, I am basically referring to b, a and c here. So sum would be minus b by a, and product of the roots would be c by a. So this is how we can find out the sum as well as product, rather than finding the roots first and then adding up or multiplying them together. So this is the shortcut method that we have, that we can use for other kind of questions also. One more thing which is there, if a sum and product of roots is known. So if somebody has told you that the sum of the roots of the equation is this, let's say here we have used the notation S, and if somebody has told you that the product is P, then you can find out the equation. You don't even need to be told the equation, you can yourself find out the equation by using this particular formula. And the formula says x square minus sx S stands for sum, so whatever is the sum of the roots, you will put it here. Sx plus p is equal to 0. Whatever the product of the roots, you will have to put it here. The sum has to be put here. And do not forget, students tend to forget this kind of sign. So you have to remember this sign, x square minus sx plus p is equal to 0. So even if you do not have any equation with you, this means what? You don't have any equation with you. Even then, if you are told what is the sum of the roots and what is the product of the roots, you can find out the equation. Now remember this. This is first implication for you. So if the sum has been given of the roots and the product of roots has been given, you can find out the equation. Again, another implication for you is just by doing this, you will find out whether there are two different roots, which will be the case here, real and equal roots. The two different roots is not the case here. The two different roots is the case here, and this is basically two equal roots, and I have given you the reason also. And this is the case when you will not be able to really find out the root, because roots are basically imaginary. So this is one more thing that you have to remember, and the implication for you is that just by looking at this, you can understand whether the roots that you will obtain by calculating the equation would they be real or equal or distinct. Is this okay? Please also understand, it may so happen that you are doing the calculation, in the end you are finding the two values of x and the two values of x are coming out to be the same, which means we are talking of this particular real and equal roots. So two values are coming out to be same means the two roots are equal, so you would definitely be getting just one value. So when you solve the question, you will be getting two roots and the value of the two roots would be the same. So this would be this case, and it would satisfy this particular equation also, minus 4ac is equal to 0. Is this okay? So this is another implication for you. Likewise, by looking at the equation, you can find out the sum of the roots and the product of the roots, and then you can use this information to find out the two roots. You can find out the two roots also. So how do you find roots? That we are not going to discuss today, but you can easily find out the two roots when you have the sum of the roots and the product of the roots. It's like saying you have the sum of two numbers and you know the product of two numbers. So can you find out the two numbers? You can. So likewise, if you have the sum of the roots and the product of the roots, you can easily find out the two roots. So you don't need to solve the equation like this if you have been given the sum and the product of the roots. Is this fine? So let us attempt one particular question and let us try and understand this better. So in this particular example that I have taken up, this is an example that was given to you as an assignment also, and probably this also appeared in your test, and this was the reason why this is the reason why basically I'm taking it up as an example. You have already calculated the roots of this particular equation, the two values that you get, so you can always refer back to that calculation of yours, and you can again do the same calculation using the factorization method or the Sidracharya method. What I'm going to do for you today is I'll find out the sum and the product for you. So comparing with ax square plus bx plus c, this is what you have to do. You have to basically now compare ax square with cx square, just like we have been doing earlier also. We have been doing all this while compared with plus 13x, and c, the remaining portion, gets compared with plus 5. And this way we'll get a is equal to plus 6, b is equal to plus 13, and c is equal to 5. Plus signs have not been mentioned because you don't need to mention a plus sign. So we are not mentioning plus sign as such, but a means a is equal to plus x, 6, b is equal to plus 3, 13, and c is equal to 5. Now that we have obtained this information, now what we can do, we are going to first check whether the roots are real or imaginary, and whether roots are equal or distinct or unequal. So we have done what? B square minus 4ac, we have put in these values here. So you can do this calculation on your own. So don't just keep looking at the screen. You please start doing your calculation on your own, and that is why I'll be moving a little fast now. So this will come out to be around 49. Now 49 is greater than 0, which means you will get real as well as unequal roots. Basically there would be two distinct roots that you will get. So this is what you can simply find out using the b square minus 4ac expression, and we have seen in the slide that if b square minus 4ac is greater than 0, so naturally the roots are real and unequal. Now what is the sum of the roots? Again, we have already done this, minus b by a. So what we'll do, minus b by is, this minus is very important, never forget this. B is equal to 13, the values b by a minus 13 by 6, and this is what the sum of the roots is. What is the product of the roots? You know that the this is c by a, and again we'll put these values from here. C is equal to 5 and a is equal to 6, so you'll get the product of the roots as 5 by 6. Is this okay? Equation. Now what we have to do basically now is that we have to find out the equation. So what we are going to do, we are going to make use of this information that we have, and let's see whether we are able to find out the equation or not. So what we are going to do now is have a look. Equation, you know already that how to find the equation. X square minus sx stands for sum and p stands for product. So what I'll be doing, sum is here minus b by a and product is here c by a. So I'll be putting these values. So x square minus, instead of, in place of sum s, I'll put the value here, this value here, and then in place of p I put this here. So x square minus 13 by 6, x plus 5 by 6. I hope you understand that this minus will lead to a change in the sign here, so it will ultimately be plus 13 by 6 x. And then what we are doing in the next stage is we are going to multiply the whole equation by 6. So I will be multiplying the both sides by 6. You please keep doing this on your notebooks. So when you multiply both the sides by 6, what will actually happen is you will be able to cancel out this 6 and this 6, and this will get multiplied by 6. On the other hand, if you multiply the right side by 6, 6 into 0 will remain 0. So there would be no change on the right side, and this would be the equation that you will get, 6x square plus 13x plus 5 by 0. If you are still not able to do this, what you can do is you will take LCM here. This is fine, and then you can cross multiply and then you will get this equation. So basically now you have been able to arrive at the same equation without doing anything else apart from the product. So this is how you go about finding the equation also if the sum and the product of the roots has been given to you. This is fine. Now let us verify whether we have got been able to do the question correctly. We have arrived at the correct answers, at the correct roots or not. So we are going to verify using the Sidracharya formula. We have already discussed that. So I'll be using the Sidracharya formula. You know that the roots is equal to minus b plus minus root b square minus 4ac by 2a. I have simply put in these values here, and then I've done the calculation. So you can please do your calculation on your own. So I'm just skipping the calculation part, and I'm straight away moving to the two answers that I've got, minus 1 by 2 and minus 5 by 3. Is this okay? So these are the two roots that we have got, and we are adding them up. So we are getting this sum is equal to minus 13 by 6, and again we are multiplying them up, so we'll get the product as 5 by 6. Minus 1 into minus 5 becomes 5, and 2 into 3 becomes 6. So basically now we have got sum is equal to minus 13 by 6 and product is equal to 5 by 6. Now let us have a look at the answer that we had been able to calculate there. The sum here was also, have a look at this sum here, this sum minus 13 by 6, and product again is 5 by 6, which is same as the result that we have obtained here. Is this okay? So there is a verification now that what we have done there using the formula for sum and the product, that is absolutely correct, and there is no problem with that. Okay, now if you want me to do some more questions for you, I'll do that. However, I think we have had sufficient discussion on the use of Sidracharya formula and on the nature of roots. Now the task for you would be to go back to our earlier discussion. I hope you remember the discussion that we had, and you would also remember the questions. So you please do these questions. You have already done them using the factorization method, and you have already now also done them using the Sidracharya formula. This was the assignment in the last session. Now the assignment for you in this particular session is kindly attempt these questions using the method that I've discussed today. Find out the sum and the product of the roots, and then please cross check your answers with the answers that you have got using the factorization and the Sidracharya method. So you must have got the roots in the Sidracharya as well as the factorization method. You please add them up and also multiply them up, and then you find out whether the value that you obtained by using the formula for sum, that is minus b by a, and the formula for product, that is c by a, do these values match the results that you had obtained there when you were using the Sidracharya formula and the factorization method. Is this understood? So that is all from my side. I would be now moving on to linear equations. I think we have had sufficient discussion. What is probably left is you people attempting more and more such questions so that you gain a good command over how to solve these questions. So the advice from my side is please keep solving the questions, and very soon we'll be having a test wherein some of you who were not able to score in the last test, they will get another opportunity to score marks. So make sure that this time you are well prepared. So keep practicing hard. This is the bare minimum that you have been assigned. You should ideally be doing many more questions. Do those questions using the factorization method, the Sidracharya method, and then cross check using the method that we have discussed today. So this will give you a good idea, and you would be able to attempt the questions also. Thank you very much for your time.